Hello, welcome to my channel Ganitavayini. I am HarshaVardhana. Here we have the first problem, that is find the square root of 16 minus 30i. Let the square root of 16 minus 30i be a complex number x plus iy, where x and y are real numbers. Therefore, root of 16 minus 30i is equal to x plus iy. Squaring on both sides, we get 16 minus 30i is equal to x plus iy whole square. Expanding on the right side, we get 16 minus 30i is equal to x square plus 2ixy plus iy square. On simplifying, we get 16 minus 30i is equal to x square minus y square plus I 2xy. Equating the real and imaginary parts of the equation, we get x square minus y square is equal to 16 and 2xy is equal to minus 30. In step 2, we use the modulus property, that is mod z whole square is equal to mod of z square, allows the another equation involving x square and y square. Therefore, the modulus of 16 minus 30i is mod of 16 minus 30i is equal to root of 16 square plus of minus 30 whole square, that is equal to root of 256 plus 900, that is equal to root of 1156, that is equal to 34. So we have x square plus y square is equal to 34. We call it as equation T. In step 3, we solve the system of equations. In this, here we add the equations 1 and 3 to eliminate y square, that is x square minus y square plus x square plus y square is equal to 16 plus 34. Therefore, 2x square is equal to 50, x square is equal to 25, and x is equal to plus or minus 5. We get x square plus y square minus x square minus y square is equal to 34 minus 16. Therefore, 2y square is equal to 18, y square is equal to 9, y is equal to plus or minus 3. In step 4, we determine the correct pairs of x and y. From equation 2, 2xy is equal to minus 30, which means xy is negative. This requires x and y to have opposite signs. If x is equal to 5, then y is equal to minus 3. If x is equal to minus 5, then y is equal to 3. Therefore, the roots of 16 minus 30i are 5 minus 3i and minus 5 plus 3i, which can be corrected as plus or minus 5 minus 3i. Here the next problem. Find the square root of 4 minus 6 root 5i. This problem can be solved in steps. In step 1, we set up the equation to find square root of 4 minus 6 root 5i. We assume that result is a complex number in the form x plus yi, where x and y are real numbers. Therefore, we can write it as root of 4 minus 6 root 5i is equal to x plus yi. Squaring on both sides, it will give 4 minus 6 root 5i is equal to x plus yi whole square. Expanding the right side, it will give 4 minus 6 root 5i is equal to x square plus 2xyi plus yi whole square. Since I square is equal to minus 1, the equation becomes x square minus y square plus 2xy into I. In step 2, we formulate this system. By equating the real and imaginary parts of the equation, we obtain the system of two equations, that is x square minus y square is equal to 4 and 2xy is equal to minus 6 root 5. We can also use the property of modulus of a complex number, that is mod z square is equal to mod z whole square. To get the third equation, mod 4 minus 6 root 5I is equal to root of 4 square plus minus 6 root 5 whole square, that is equal to root of 16 plus 180, that is root of 196, that is equal to 14. Thus we have x square plus y square is equal to 14. In step 3, we solve the system of the equation using equations 1 and 3. Therefore, x square minus y square is equal to 4, x square plus y square is equal to 14. Adding the two equations eliminates y square, that is 2x square is equal to 18, x square is equal to 9. Therefore, x is equal to plus or minus 3. Subtracting the first equation from the second eliminates x square, that is 2x 2y square is equal to 10 implies y square is equal to 5, y is equal to plus or minus root 5. In step 4, we determine the roots. From the equation 2xy is equal to minus 6 root 5, which means that the product xy must be negative value. Therefore, x and y must have opposite signs. Therefore, the two pairs of solutions for x comma y are 3 comma minus root 5 and minus 3 comma root 5. The two square roots are 3 minus root 5I and minus 3 plus root 5I. Therefore, the two square roots of 4 minus 6 root 5I are 3 minus root 5I and minus 3 plus root 5I. Welcome to the next problem, that is solve the quadratic equation root 2x square plus x plus root 2. This problem can be solved in steps. In step 1, we have to identify the coefficients and the formula. The given quadratic equation is in the standard form ax square plus bx plus c is equal to 0. Here a is equal to root 2, b is equal to 1 and c is equal to root 2. And here we use a quadratic formula to find the roots, that is x is equal to minus b plus or minus root of b square minus 4ac by 2a. And in step 2, we have to calculate the discriminant, that is delta is equal to b square minus 4ac. Therefore, delta is equal to 1 square minus 4 root 2 into root 2. That is delta is equal to 1 minus 4 into 2. Therefore, delta is equal to minus 7. Step 3, we apply the quadratic formula and simplify. We get substitute the values of a, b and delta into the quadratic formula, that is x is equal to minus 1 plus or minus root of minus 7 by 2 root 2. Since the discriminant is negative, the roots are complex numbers. We use the fact that root of minus 7 is equal to I root 7. Therefore, x is equal to minus 1 plus or minus I root 7 by 2 root 2. The solutions of the quadratic equations root 2 x square plus x plus root 2 is equal to 0, or x is equal to minus 1 plus or minus I root 7 by 2 root 2. With this, I will conclude this session. Those who have any doubts or clarifications regarding to this video or regarding to this chapter, please put a comment in the comment box. I will rectify the same. And those who not seen the video, I will put the link in the description box. You can click on the link and see the videos. And one more thing, that those who like the video, please subscribe the channel.